Hi, Nate.
Hey, Tom.
Why did the programmer use RLHF to train their pet robot?
It was going to the bathroom in the house.
That's better than what I got. Because every time they asked it to fetch, it needed positive reinforcement.
What can we say? They made it match reality. Welcome to the Retort. Today, we're going to take some more history lessons for y'all. Kind of things that seem old, but really are unfolding again as we watch them. I think this is mostly motivated by Tom's kind of deep reading in one subject matter, cybernetics, which I actually think fewer of the audience members than we would expect have A, heard of it, or B, given it much deep thought, and kind of link that to some themes we see play out in modern CS discourses on a day-to-day basis. Kind of how CS people love to be angry about other people for reinventing history every few years, even though we all do it. We all say things because we couldn't find them in the past. So I think to start, Tom, you should probably introduce cybernetics, and we'll probably add personal history for how this topic came into our research in the last few years again, and kind of take it away from there.
Yeah, you introduced it in kind of a like this is not a formal presentation or anything like that. It's going to sort of be also my musings on this topic. But yeah, I did. Our regular listeners know, as I've said, I designed my own PhD, my doctorate at Berkeley, starting in 2016, and pursued it while based mainly at the Center for Human Compatible AI for the next like 5 years or so. And a theme of that time was my periodic reading into the history of cybernetics. So, to orient people to that, during World War II, there was this issue of how do we build better projectiles and airplanes, right? So,
Projectiles,
yeah,
projectiles.
yeah,
Your pronunciation took me a while to figure out what it was. Okay, on we go.
yeah.
On we go.
The things that you throw them, and you're like, how do we make it actually hit the thing that we want it to hit? And what was interesting about that historical context was, of course, previously with ballistics and whatnot, this was basically just classical mechanics. A lot of what motivated classical physics, and specifically the work of people like Galileo and Newton, was not just these intellectual questions of like, oh, why do rocks fall at the same rate as other rocks? Or, what is friction? It was really more things like, at what angle do I have to fire the cannon so that the cannonball will destroy the fortification around this city state so that we can take it over or whatever? It was rooted in those sorts of contexts. So in a way, it's not that surprising that another major intellectual leap and the birth of a new science happened during World War II, where that problem, in fact, that very same problem, became dynamic in nature, right? So you had a context where you had missiles, I already mentioned airplanes, avionics was literally and figuratively taking off as a field of inquiry. And there was this question of how is it that in sort of real time you can anticipate where and how certain kinds of, whether they're bullets, whether they're missiles, what have you, are tracking and able to monitor their environment such that they're able to estimate the difference, the distance in real time between themselves and where they think other objects are, right? So that's kind of what made it a dynamic problem setup rather than in just classical mechanics, where you could hold some more things constant. Those dynamics became part of what we would now call the problem specification. So there was this guy, Norbert, we'll call him. Good old Norbert, who was very interested in this. Wiener is his last name, of course. And he was studying this. He was coming up with models for it. And he, was taken care of, so to speak, by the military-industrial complex for doing so. And his research took off, and he became interested in this question in a way that was, it flowered. He was sort of like, oh, these sort of formal techniques I have developed for this modeling these types of dynamics and trying to control for them. How do I actually develop that, not just on its own terms to monitor the dynamics of more and more complicated systems, maybe in non-military contexts, but more broadly, and this is where it gets interesting, reconceive what metabolism is, or what society is, or what makes one animal different from another kind of animal in terms of this new way of thinking about dynamics. In other words, how is it that you think about living things and how they move through the world, make sense of the world, pursue things, and all sorts of other types of behaviors in terms of feedback, in terms of the ambient monitoring of information in some environment.
What was the extent to which these ideas caught on? Who resonated with them and or put them into practice?
So it became a whole field of inquiry, and as we've been discussing it, so Wiener named it cybernetics. The word cybernetics comes, I believe, from the Greek word for a helmsman in a boat. So basically, like, picture somebody at the rudder of a boat. I think today we would just use a term like tiller. But basically, the Greeks would refer to would call this like it's cybernetics in the sense of like that's sort of like what that person is doing. You're monitoring, the kind of dynamics in this case of the water, but also how that cross references against the air current, the sails, the tip of the boat, other people in the boat, all that stuff. That's the sort of metaphor that guides this, and this became a field. It became an interdisciplinary field very quickly. It was originally comprised of people who, and also, by the way, this is all happening at kind of literally the same time that what we now call computer science was becoming a thing. So it's not like computer science was already a field and cybernetics grew up in relation to it. If anything, they were kind of growing up at the same time at somewhat different universities. I believe Wiener was at MIT. What we would now call computer science was really taking off at Princeton, along with a few other places. But this was originally comprised, in its full flowering, and there was an event called the Macy Conferences, and there's a good book on this called The Cybernetics Moment that goes into
I want to
this.
link back to some of our weird other esoteric podcasts. Is there any links with this happening at Princeton to kind of like the Institute of Advanced Study and them trying to have all the top physicists there at the same time? Is that the same time period? I'm thinking of the Oppenheimer episode.
Right. So the Institute for Advanced Study was a major player in computer science. To my knowledge, it was not a major player in cybernetics. I could be wrong about that, but it's not a coincidence to the extent that the Institute for Advanced Study is where John von Neumann was working. It's where, his collaborators were. I believe, I could be wrong about this, but my recollection is that it was in actually the basement of the Institute for Advanced Study that one of the very first, maybe the first post-war digital computer, was built. And in fact,
my reading, if there's not direct links of collaborations, these people were socializing. Like, these are small worlds then.
For sure.
Like elite scientists at the time.
So maybe this is an ambitious question, is what relationship, which is I guess what this episode maybe is going to be about, is sort of what relationship does computer science have with cybernetics? It is important to understand the difference in focus where, and I'm speaking more to the cybernetics side of this, it's the scientific study of feedback. and feedback as a kind of metaphor for many different processes in both natural and artificial systems. So the Macy conferences that I was mentioning originally were comprised of really almost any field you can imagine that might be interested in that. That did include computer scientists. It also included information theorists. Claude Shannon was there. Norbert Wiener himself was there. Margaret Mead was there. Mead was a very famous anthropologist. She did her field work in um, the Polynesian Islands, I believe, South Pacific. She was studying tribes there, and she is most famous, I suppose, in public spaces for being one of the kind of influences on the sexual revolution. So basically, she did this field work showing that the sexual practices and rituals of tribes in the South Pacific were very different, but also in some ways maybe much healthier than the kind of neurotic sexual practices or lack thereof of
Wait, what
America.
is the link? Is this based on like some study of dynamics?
Well, oh, the link to cybernetics. That's a
Yeah.
good question. Well, no, I think in Mead's case, what she was interested in and where cybernetics went intellectually in the lead up to and during the Macy conferences was it became very interested in how feedback described not just the way in which some system, or you could say an agent, I suppose, is monitoring its environment in terms of feedback, but also, and this is where it gets a little bit crazy, it's also in principle an interesting way to think about how a scientist is modeling how a system learns from its environment. So
Yeah.
this became known as what's now called second order cybernetics, where, and actually I think the best illustration of this, it's a little bit cute, but the best illustration of this might be like MC Escher paintings. So if you've seen the famous drawing of a hand that's drawing another hand, and that hand is then
Yeah.
going back
Or
to
the
draw the other
infinity
one.
stairs.
Yes, or the famous in the movie Labyrinth. I think also there's like a whole set piece about that.
Yeah.
The stairs that go in more than one dimension at once, and you see people walking up or down them, and it's meant to be it's kind of mind bendy by definition. And then frankly, this is important that cybernetics, when that fully happened, when the transition happened from Wiener's initial kind of figurative depiction of feedback as something that's an interesting way to think about systems in lots of different environments, transitioning from that to say, how should we reconceive of what it means to be a scientist or be a modeler or be an engineer in relation to the systems that we're building, where we model the modeler and so on. That then fed very much into, I'll just sort of say in passing, the 60s, by which I mean and sex, drugs, and rock and roll.
Yeah. It's like, what does it mean to be a person in the system?
Yeah, and a certain flavor of second order cybernetics really leaned into that kind of spirit. Others did not, and the long and the short of it is that cybernetics, which had been for maybe like 20 years or so, a very vital intellectual movement, an academic movement. There really was sustained research on this. There's actually a whole other side of this, which is Soviet cybernetics. I don't know if I'll get into that in this conversation, but it's actually very important. It's a whole other side of this, of how this played out in terms of the Cold War. But it basically disintegrated when it became unclear how you model the act of modeling feedback in terms of feedback. And that did feed into the zeitgeist.
And so we have to kind of decide, where does third wave cybernetics come in? And the other thing we have to do is start talking about CS. So, and how CS compares to kind of this view of feedback is worth saying.
Yeah, so to me, this is sort of where I maybe become as interested in your take on this, Nate, as my own. But yeah, I mean, go ahead.
There's a few things we have to kind of walk through to get to the logical reasoning of why we're here. I think the first thing is important to say, like, our views of how computer science is conceived in an educational sense, like how people are taught to believe as a computer scientist. Caveat, neither of us had formal training in CS. I did undergrad in electrical engineer, which is much more about like models of the world. CS I generally think is heavily based on logical thinking and abstraction, which is about like containing your solution around a few basic principles and assumptions of the world to design different types of efficient solutions and like how to do this. And software engineering closely falls out of that with designing systems that match these principles and work well with each other. And then the kind of key tension in my mind is between the notion of abstraction and the notion of dynamics. Because to be good at abstraction is to be good at ignoring dynamics. And I think this is the tension that kind of led us to our work and where I learned about third order cybernetics and kind of where a lot of my previous PhD work on reinforcement learning, which is about trial and error learning, which is about feedback, kind of intersected with some of this. Where is society going with AI, and like what can we possibly measure about AI, and like the fact that you realistically can't draw an abstraction around the powerful AI systems that we have today. Like the final abstraction that we're at is all of modern digital society, and trying to do that in a computationally efficient manner is impossible. So it just shows the challenge that we're at. So there's a few places to jump in. You can talk about CS again, or we could talk about reward reports and all the like how we ended up doing that and stuff.
Right. So is that how we're framing third order cybernetics? Was that the
I
jumping
don't
off point?
remember what third order cybernetics is, so wherever the right time to tell you the definition is up to you.
My sense, yeah, my sense is that what may or may not constitute a third order cybernetics is a major open question to which you and I in our collaborations and also separately have contributed. That's the way I would put it. I
That
may
makes
have more
sense.
to say about that at some point, but I think I'll leave it there for now as far as what third order cybernetics would mean. But broadly, the way that Nate characterized the setup is that yes, we are now in the position of building systems based on abstractions that are inducing dynamics themselves. And we are grappling with how to theorize that, how to investigate that, how to model it, but also how to intervene on it in ways that are desirable. Where desirable means different things depending on how much we care about accuracy and how much we care about, for lack of a better word, the good.
Okay, yeah, we have to walk people through a few levels of this. I think to start with, there's the kind of idea of what happens to society when you deploy a machine learning model in systems. So we've dealt with things like Google search, Facebook recommendation algorithms, and things like this. If you assume, or like, I mean, as a better example, might be like an image classification tool in your phone for searching images or something that like you don't really think affects your opinions too much. And what does that do to the world? And like, how does that shape how you act as a human, and how are you kind of captured in the dynamics of that system? And I think one of like in this kind of cybernetics case, it's like how does the human, how does the human get affected by this model? And a lot of our work is kind of understanding how to frame machine learning systems and how the like human user is likely to be an underspecified part of the dynamics. So if you're an ML designer, you generally think of the user as providing data for your model, or like is reduced to like a scalar value of like engagement or something like this. And a lot of the work is which we has been captured in things like clickbait. Like clickbait is now a story of how machine learning models changed internet dynamics and changed user preferences. Is how could that type of story be captured into machine learning systems and people's understanding of society and risks? And then the long term of this is going is like what happens when machine learning systems can act and decide on their own, and how do you create a problem specification around there? So are they kind of starting with the kind of like clickbait example, and then we could build the reasoning It could probably be the culmination of the episode doing that.
Yeah, we are concerned with these cases where you are accidentally, as a designer, designing incentives for people to interact with a classifier or a model or a system in ways that over time break the assumptions under which that classifier was assumed to be accurate. In other words, at the end of the day, it almost doesn't really matter how representative your data distribution was on which you trained the model. If the model capabilities are so great or so transformative of the domain that effectively just it sort of just naturally unfolds this different kind of social dynamic between people on top of it. Another example would be something like, even you could argue, the phenomenon of influencers on different social media platforms is something that only makes sense once you have recommender algorithms that, even if they're not fully transparent, are sufficiently intuitive to certain kinds of content creators that they can effectively create sui generis content and distribute it according to the logic of that classifier in ways that, and again, that's not to say that's bad. It's just that it's an extremely difficult thing to itself to design for, and it's not clear qualitatively what the impact of that will be over time. What we are seeing is that many of these induced dynamics seem to be bad, either because,
To put it simply enough.
to put it mildly, either because it breaks the classifier or, more perniciously, because it breaks society without breaking the classifier.
Well, I think to break society point, we have to continue to the higher level thing, which is what happens when this newsfeed algorithm is an RL agent in itself. So an RL agent is something that hypothetically learns on its own. It's retraining itself in real time. Its actions are some sort of input into society, and it has a goal. A goal could be to maximize engagement. It could be some bullshit made up latent variable, like make the algorithm score go up. Like, we don't know what that means. But the idea is, like, what happens if your machine learning systems are told to optimize on their own in the style of RL? And we're trying to recast this in the style of quote unquote RLHF, and this, like, what ChatGPT is doing with reinforcement learning from human feedback and kind of reintegrating future data. Is like, what do the futures look like when all of these things are on their own? And I think that's where kind of this third order mystery cybernetics comes in.
It's
I
not
might be
clear. Well, I already articulated it in my mind as an open question. Yes. I think that the new landscape that opens up is something like, what is the purposiveness of these activities that involve humans when so much of that is automated and outsourced to a non-human strategic agent that effectively we're just sort of spinning outward societally in directions that are not under our control and actually maybe not even fully understandable to us. That does seem like a distinct landscape of questions, even from second order cybernetics. But I should clarify that, and here's where I speak also kind of as a political theorist, that isn't really maybe a new problem. If you go back even farther in time, I don't know how many of our listeners are familiar with social contract theory or ever had to read like
Very
Rousseau or John Locke. Basically, there is an even older set of questions in philosophy about where does inequality come from in society? The fact that, some people are rich, some are poor, some are beautiful, some are ugly. These are not natural categories, or at least many philosophers would argue these are not. These are socially constructed categories. They must come from somewhere. And even hundreds of years ago, there were very cogent arguments made about how those sorts of dynamics emerge and are induced by different kinds of infrastructure. And maybe I'll just have to say this provocatively for this episode, I'm not sure, but a lot of my recent work has been about rethinking the systems that we are just now building or on the cusp of building in terms of actually very old metaphors for social order, infrastructure. One example of that I can give is, I mentioned recommender systems. I have a project with a collaborator, Nate Lubin, my other Nate L, as I call him.
To be confused. We have literally been confused by other people.
Yeah, I've also confused you guys before in my meetings. That we have a project together where I have worked on assembling a kind of deep analogy between the normative and social and ethical problems that digital platform recommenders pose to social order, analogizing between that and public health infrastructure as started to become a problem in the 19th century. So, for example, rather than thinking of the way you fix social media as by hiring more content moderators to sort the differences between acceptable and unacceptable content, instead you think of it as something more like a sanitation system, where there's a very different kind of set of metaphors for how you would monitor such a system, and how the way you would fix an epidemic of misinformation is not by hiring lots of nurses, but by creating these kinds of choke points in the distribution that you can monitor and evaluate the impacts so that you can effectively have a greater degree of control and oversight of the dynamics of the system rather than the points at which it's already effectively too late to make a difference. So it's kind of, again, an everything new is old again kind of.
This is the last thing with like RLHF. It's like everyone's like, this is the technology that tests what it means to be human. But so much as what you think it means to be human is about living in modern human society. These questions have gone through the debates like this in terms of feedback and how external effects not monitored or not designed for in technology affects everyone else. And this happens in this debate. It also happens at a technical level. I think the technical debates are even funnier, which are like old academics coming out of the woodwork and being like, but my paper did this in the 90s. And for the RLHF example is all of the preference literature from the 2000s on machine learning of preferences before deep learning was big are just being rediscovered, and they're just kind of being raked over by RLHF. It's like hilarious how bad the literature review and coverage in this is, it's because it's a complicated area, but there's tons of many examples. And this is how we have Schmidhuber, the famous "I invented this 20 years before you were alive" meme now, with all the undergrads being super young. It's the more sophisticated lens of it. It's about the real world impacts more than academic flag posting.
Right. And so another example of this recent paper that Nate Lambert and I and Tom Zick, a friend of the podcast, have together on the history and risks of reinforcement learning and human feedback is really, I think, also exemplifying what I'm saying, which is, in order to understand what is, in fact, I think, legitimately new as at least in terms of fine-tuning, it's actually very productive to go very, very far back in time, to go back to the ways in which different ideas, assumptions, theories, interpretations of what feedback is, what preferences are, what people are, what values are, first crystallize. When did they first crystallize? In ways that those ideas can be made modular and therefore sandwiched, in relation to each other, in terms of really what's just a giant machine learning pipeline. And I actually think I should, again, to confess, I'm not sure if I've actually updated the paper enough to add in the full gist of it, But these are actually ancient questions. This is sort of Plato versus Aristotle all over again. Is the
Yeah,
good
I did
something
add the
that...
citation.
Oh, did you? Okay, yeah. Okay, so I need to... But it's in process. Yeah. So yeah, I mean, this is I think for me, it's interesting. I've been reflecting on this recently. If I were to take a stab at what does third order cybernetics mean for me, I would say it's something like rethinking not just systems monitoring feedback, and nor just how people who are building systems are also defined by feedback, but actually how the essence of what is of value and what is purposeful is defined through feedback. The fundamental structure of value is itself something that can be understood in terms of feedback. I suspect that's the kind of massive, vastly still unexplored conceptual technical landscape we're heading into, and that is implicitly at stake with RLHF, but also with societal scale AI as a whole.
Yeah, and I think to tie some points on the kind of AI feedback thing is Google and places have thought about this, which is like scaling RL experiments to use feedback in real time. And they've all been instantly like stopped by practicality concerns of it just not working. So like we are not the only people to find this. Like we find this interesting from a like what is good point of view, but there are clearly people that are also finding this interesting from a this is a powerful technique point of view. And I don't think Google updating its YouTube algorithm in real time in your Chrome tab is anywhere near to be true. But it just goes to say that this is not only an academic problem, but like feedback is known to be powerful. I think most of our audience are probably also not electrical engineers. I have no idea who our audience is. These are all assumptions. Maybe they're all super well read than me, but like electrical engineering is like so modeling systems, and you learn all about feedback. Like feedback is a core technology that enables many modern tools we rely on. So it's not surprising to see so many machine learning leaders want to harness that power. We just kind of want the broader context to be included in that conversation.
Even as that broader context is transformed by this infrastructure, which is what makes it challenging, which also takes us to reward reports. I don't know if that's something we want to get into briefly on
It's
this
at least
episode.
telling people that it exists.
Yeah, I think reward reports are sort of applying the mindset of cybernetics to documentation. That's a way to think about it. So AI documentation, it's a hot topic. It's been a hot topic for a few years now. It's best represented, I think, still by work like model cards for model reporting, data sheets for data sets, where you are taking, you're concerned about the possibility or inevitability maybe of bias or inaccuracy or fairness or unfairness as it might manifest in some classifier. And so the question then is, how do we do a better job writing down the critical features of the components that underlie how that classifier was trained or on what it was trained, so that there can be not just a record, so there's some kind of maybe an inkling of accountability there, but also the possibility for discretion and good judgment about whether a given classifier is in fact appropriate or inappropriate for a particular use case. So, it's, I think one of its claims to fame, of course, is this ability for a model card to give you insight into whether or not a given facial recognition classifier is acceptable or not, maybe for a particular application, like at the airport, something like that. Maybe that's a different context than using it in some other environment. But then also, of course, making it so it's not systematically biased against people who look different, right? So this is kind of the heart of the gender shades paper, other work of that kind. That's sort of what AI documentation, that's been a lot of the spirit of it. Where reward reports jump off from that is to draw on these intuitions we've been exploring in this conversation, which is, well, you can take snapshots of those components, but that's a very different problem than how you should understand the emergent relationship that forms between a system and its environment, where you have to monitor the holistic behavior of that system. You have to repeatedly observe the interactions that system has with its surroundings. And then you have to also somehow extract an understanding of what is changing in that environment or about that environment as the system intervenes on it. So you're no longer holding those things constant, the same way that Norbert learned not to hold certain things constant when he was modeling, whether it was throwing things in the armed forces or whether it was understanding metabolism or things like that. When you're trying to build in a fully dynamic approach, what does that ask of documentation? And so what reward reports are is an attempt to try and formalize what that procedure might look like by borrowing the language of reinforcement learning. So we sort of use RL, and specifically the RL notion of reward, feature specification, other things about the environment that may be of relevance, to in effect write down what the system has been told to optimize for and why, and then regularly update that documentation over time as the behavior may shift. The idea being, the way I would characterize it, is that makes documentation into something more like a science of accountability, where you're able to treat assumptions about the system pre-deployment as hypotheses about its future performance.
And this might be why reward reports is so much harder to uptake. I haven't actually said this before, so this is good new content. Model cards and data sheets are primarily about transparency in my mind. And in that vein, transparency is a little bit easier to gamify and mislead on. While reward reports are fundamentally built as a tool for accountability because they take deliberate engagement over a period of time, which makes uptake even harder, because misleading on accountability is probably just going to get you called out and totally vilified if you're a large, powerful tech company. If you're just BSing your way through like anything that's supposed to be accountability, you're just not going to go well. So we haven't said that before, but that rings well with other metaphors we've used on motivating our work and kind of the challenges you're going through into making this into a real tool that people are using. And for the record, Tom's working with like public entities to try to get this off the ground. We'll edit that out if it's not allowed to say, but public entities are more inclined to be accountable. Like they are by definition, like they're required to be, otherwise everyone will lose their jobs and things like that. So I kind of like that as a little realization at the end. So that was useful.
I agree. Model cards and data sheets were instantiating transparency in documentation. Reward reports are meant to manifest what accountability could look like. And that is, frankly, a much harder problem. But I'm also confident that it's often really what's at stake here is figuring out what is that relationship? What is it? What should it be in order for us to be able to make truly verifiable claims about what it is that we're building as the capabilities mature. So that's and that's all tied in with what I think again is this kind of if we want to call it third order challenge. How do we frankly re-envision what the good life is, what the good society is in the frame of feedback, in the language of feedback between systems and within systems? Because unfortunately, we're now very much in the position of putting the boat in order while we're already setting sail and hoping it doesn't sink. That's sort of where we are. We don't get to be in the position of abstracting from the shore about what a perfect boat would be and then hoping we can build it. We have to somehow build it as we go.
Very true. Is that the metaphor we sign off on? Do you have anything else to add?
It's interesting. There are some mysteries here that are very deep. I've been reflecting. I was telling Nate before we started recording, I've been doing some automatic writing recently and really just allowing myself to free associate where I think AI governance is going, AI ethics is going, and recent events, again, have kind of just reminded me that we are in a profound state of vulnerability and ignorance about even what we are building as we build it. And that's pushed me in some interesting directions about thinking about what is the form of life and form of purposefulness that we are building with reinforcement learning, and what does that ask of us? What does democracy actually look like in the context of systems like that? Does it just look like auditing them? I don't think so. It's much deeper than that, and that's very exciting.
Yeah, it sounds good. I'm sure we'll keep digging into these. Hopefully, we get to share our pretty faces with everyone on the YouTube. So, like and subscribe, whatever. I think we can sign off. The sun is setting behind the Salesforce Tower, and the fog looks really majestic over the Golden Gate right now for anyone who's wondering. So, that's probably the good life. That's as close as I'm going to get this week.
I was going to say, it sounds kind of dystopian with the Salesforce Tower, but if it's pretty, that's good.
Yeah, that's where we're at.
Cool. All right. Bye for now, everybody. Thanks
Bye,
for listening.
everyone. Thanks again. Bye bye.